Alright, by now, quite a few of you have gotten bitten by the ham radio bug. And the one thing that's keeping a lot of people from getting involved in amateur radio in general is the price. People don't want to go ahead and spend $3, $4, $5, up to $600, even up to $1,000 to get into a hobby to find out in the long run that it's not going to be something that they're going to enjoy. But that doesn't mean you have to not get into it. Today we're going to get into modding FRS radios. Now a lot of the hardcore, die-hard amateur radio guys are going to piss and moan about this, but the way I see FRS or PMR radio for Europe, which are the simple two-way radios, I've showcased these on the show before. Now, they're going to piss and moan, oh, this is like the instant messenger, MySpace, Facebook of radio. This is where all the flamers and all, you know what, the bottom line is, it's a radio. You know, if you give people the tools to become an asshole, they will be an asshole. Yeah, there are a lot of assholes on the FRS and PMR bands, but you know what? If it's just you and a couple of friends playing around with antenna designs and just different operating modes, that's great. I'd rather experiment on this rinky-dink $15 radio, rather blow out my $250 handheld. Now, these radios do operate very close to the 70 centimeter band of amateur radio, which is in the 440, 450 megahertz range. I'm not going to get too specific. These operate 460, 470, 480, depending on what region you're in, so look up the frequencies. But reason being is because PMR and FRS radios are so close to the amateur radio 70 centimeter band, I'm going to get into a bunch of antenna designs later on, which will also be applicable for FRS radio, and I'll actually show how to design the antenna dimensions for both amateur radio as well as FRS, so you guys can get started into the wireless wilderness. The first thing we're going to need is a radio with an antenna jack. Unfortunately, if you want a PMR or an FRS radio that has an antenna jack, you're going to be paying quite a bit of money for it. And as technophiles, we're not going to go and settle for that. So in this segment, we're going to go ahead and modify two different radios with two different RF jacks, much similar to what we've been doing with the Wi-Fi. But being that this is a lower frequency, it's a lot more forgiving for mistakes. So let's readjust the camera. We'll go to the table side and get started. There is going to be quite a bit of improv in this segment, so take what you've been learning from the show, from past seasons and episodes, to heart when doing this. These are the two most typical sized radios. Now this radio actually has a coil antenna, which we'll get to in a minute, and this one is quite literally just a piece of wire. Now we're going to need some kind of RF connector that'll be able to handle the 70 centimeter or 450 to 480 megahertz frequencies. Now, I have a chassis or panel mount BNC connector. I'll put a picture up, and I've got a standard polarity, not reverse polarity, SMA. Now, this is actually a really easy mod to do, especially when you have a smaller radio. We're going to put this into this one. We're going to put the BNC into the larger radio. But if you notice, both of these connectors, much like a lot of the ones that we've worked with Wi-Fi, in fact, if you weren't told, this looked exactly like the Wi-Fi ones that we've been working with in the past. They've got these little nuts and washers on them that allow us to mount it into your device. Now the one thing I like about this is actually a GPS cable. This goes from an MCX to a standard polarity or just a regular SMA jack. You can buy these things off eBay pretty cheap. It's kind of hard to find panel mount female BNC jacks, so you might actually just be stuck buying one of these cables and then sacrificing. You'll probably just cut it about there and splice it in. This would be the easiest solution if you really wanted to do this. Like I said, they're really easy to get, and they come pre-crimped onto the coax. Now, as always, if you're using coax, you're going to have to use something rated for the frequencies that you're in. LMR 195 that we have been using for Wi-Fi is more than enough. However, it does get a little inflexible. It's kind of rigid. This is actually RG 174. Now, if you have leftover RF jacks from your Wi-Fi experiments, they will also work. Just compensate for what components you have in your area. Alright, so basic tools and plow, we're going to need a soldering iron, basic cutting and fabrication tools because we're going to have to chip away some plastic and cut some plastic away. We got the multimeter just in case the tester shorts, we got a fuse, and I got a hot glue gun here. I would really recommend epoxy putty, or even Gorilla Glue. But just for the first time's sake, so you can get used to what you're doing, hot glue can be removed easily if you make any mistakes. Once you know your design works, go on to something a little bit more permanent. And of course, you know, we've got a utility knife because we're going to have to do some cutting. Alright, I'm going to clear the table off, and I'm actually going to start on this one. This is actually a Motorola Talk About T5320 radio. This one is just a cheap-ass, off-brand Maxis GRMS radio. Both of these radios only have about a 1/4 watt power output. That's pretty much standard. Some radios say they can go up to an 8-mile range, but I really wouldn't hold my breath on that. Some radios can go up to a 1/2 watt. I don't care how many features or how much you pay for a radio. The most important thing about your radio is the antenna and the power output. So these have shitty antennas, they have shitty power output. Let's get some better antennas on these so they're not as shitty. I've gone ahead and removed all of the screws from the radio, and as you notice, it just comes in half like so. Here's our antenna. The antenna mounts to this small little trace right here, this copper pad on the PCB. This is your signal. The reason I know this is because when the antenna is in place, it quite literally gets screwed down into this area like so. Now if we take a look at this antenna, it's nothing more than a coil of wire. Of course, not the most ideal thing, but later on we're going to have to replicate or modify this so we actually have an antenna on this thing. Now we need to go and find a ground point. Now the reason I decided to go with the BNC connector, let me take off this nut and washer and I'll show you why. Now we are going to need a little bit of wire, and we're going to have to go and manipulate this a little bit, but not by much. If you notice that the BNC connector fits in almost as if it was designed to, but it goes down a little too far. We need this signal wire here. We can run a small amount of everyday Joe Schmo wire and connect that, and the shield needs to find another common ground point. So if we take the multimeter and we test for continuity, as always, radio circuits have a tendency of using a common ground, and we're just going to test for continuity. So let's see, negative pad, there's a negative pad there, that's not a negative pad, that's not negative, that's not negative, there's a negative. Well, if we know that this is a negative ground right there, we could probably take our shield, which has, let me see if I can get a nice good shot of it. It's got this tab right here. We can take that tab and solder it to the ground point right here. So we have our signal and ground. So we're going to fire up the iron and we're going to get that soldered in place. But as soon as you try to put the radio together, you'll notice that it's got this plastic tab right here. This is where the antenna used to go. This tab is going to get in the way. So we're going to have to use our fabrication tools. In this case, I'm just going to use a pair of wire cutters and maybe even go through with the Dremel. If I can, I'll just use a razor blade, but we got to get this post out of the way. Now what's bad about this is once we get rid of this post, we're actually doing structural damage to this. This screw holds the radio together. So we need to make sure that we don't destroy this to the point where the radio will fall apart. And we might actually have to compensate later on to make sure that there is no looseness to this, because you don't want to put too much stress on your RF point and it break off. So let me cut frame, get rid of that post, fire up the soldering iron and get to work on this. I've already gone ahead, taken a small length of the RG174 from that cable I explained earlier. Now you could use plain wire, typical 20 gauge copper wire, but I'd highly recommend trying to stick with coax. Now pre-tin the wires, and I'm going to pre-tin the actual pads on the board. Let me make sure I'm on camera with this. Got one here. And we got one here now. I'm doing this inside the case, which is a really stupid idea because the heat will probably start melting plastic. So you got to be careful for that. Now, am I on frame here? Okay. So we're going to tack the signal to the signal, much like many of our Wi-Fi cards and Bluetooth cards we've modded. And we're going to tack the shield to the shield, just like so. There we go. Now, this coax is going to have to lead into the BNC connector. And the BNC connector actually has a solder cup, which will lead in a certain amount. Now, I've trimmed this a bit long, just for this sake of you can't cut something to be longer. And this should fit inside the solder cup. Sorry if I'm getting a shitty angle on this, but it's really hard to do this on frame. Where am I on frame? There I am. Alright, so there's the solder cup. That's just being held in by gravity right now. I'm going to go ahead and feed some solder in. You've got to be careful not to use too much heat, because it's just like with the Wi-Fi mods, the dielectric material, this plastic on the center conductor, doesn't like to be very hot. Now we're going to just take this, and there's a little tab on the actual connector itself right here. I want to pre-tin that real quick. Try to bend this around so I can get it on frame. Am I on frame? Yeah, I'm a little high. There we go. Now this will be a little bit harder to tin because there's a lot more metal to it, but once you get a nice piece of solder on there, I'm just going to kind of hoax everything into place. I didn't bring any of my decent precision tools, so I'm just going to do this by hand. There we go. Now this RF connector is soldered on. I'm just going to loop it around. And if you notice, I have this nut set down kind of far on the collar of the actual BNC connector. Reason being is we don't want the BNC connector to push in too far. Now you got to remember, you do not want any of your signals and ground leads short-circuiting. That'd be really, really bad. Now at this point, I would just slather a whole bunch of hot glue in here. I'll do that off camera. We'll reassemble it. But even before you even go to the hot glue method, where's my multimeter? Make sure you don't have your signal and your shield shorted. So here's our shield, here's our signal. If it beeps, we're fucked. Alright, it doesn't beep. That works, which means we have signal to signals working and shield to shield working. Now this is a really sloppy mod, but being that it's such a low frequency and the wavelength is a lot bigger than 2.4 gigahertz, this sloppy seconds job will work just fine. I'm going to cut frame, going to slather some hot glue in here, put it all together, and we'll get to the next radio. There we go, all nice and modded. We got a huge heaping slathering of hot glue around here. Like I said, typically I wouldn't use hot glue, but if you're a beginner and you don't really know what you're doing, hot glue is removable, epoxy isn't. I'm going to go ahead and put this thing back together screw by screw. One thing that really should be done though is putting another ring of hot glue or even epoxy putty around the edge of this so it adds some strain relief. Because remember, if you're going to be putting antennas on here, you're going to have coax or larger antennas that could put a bit of stress on this, and you don't want the hot glue to eventually weaken up and break off. So I'm going to get to putting this one back together and finish it up. It's not the prettiest mod in the world, but it works. It works really well. Not really much more I can say about this. Now you can go and design whatever antenna you want. You can hook any kind of coax into this using a BNC connector, or if you go and get a BNC connectors are often used for AV equipment, high-end AV equipment. You can get expanding Gorilla Glue and some kind of metal. This is actually a street sweeper bristle that I coated in black nail polish so it wouldn't get all rusty and disgusting to hell. Solder the metal wire of whatever the hell you can get at whatever wavelength that you're using. Let's say if you're using 467 megahertz, you'd cut this to a multiple wavelength, either quarter, half, three-quarter, or full wave. I like using 1/4 just because it's not as big. You lock it into your radio, there you go. Now you have a radio that has an antenna that doesn't suck. And if you want to go directional, you can go directional. Now, let's go to the smaller one. Alright, as you can see, this radio is a whole lot smaller. This is the antenna that I pulled out of the last radio. Here's the antenna that's in this one. As you can see, it's a lot smaller, which means it's going to get quite a bit less range. Now, using common sense, we can actually see where the antenna leads into. There's a very small, thin pad. We need to find a ground point. So again, using our continuity tester, we're going to go to the negative lead on, let me switch my leads here. We're going to go to a negative lead on the battery pack, since we know radios use common ground, so this crystal should. No, what about this RF box? Yep, this little box right here has ground. There are also these little tabs right here. I don't know if you can see it really well. You see that little tab that's bent to the side? That's actually used for holding the LCD in place. We can use that. There's another one here that should work. And where's the connector? We're going to use this really, really small SMA connector with some RG174. And what I'm planning on doing is trying to get this as close to the base as possible. But if you notice that the heat shrink of this, well, how am I going to solder to it? it's heat shrunk. So what I'm going to do is I'm going to take the cable, loop it back around to the points, and make a really big U-turn like that. Cut off some of this plastic where the antenna goes, where antenna would be, and then use the mounting hardware that came with this to affix it. So let's start soldering. I've gone ahead and removed this little rinky-dink piece of crap antenna, and if you notice, I've cut a nice chunk of the original antenna housing off, so I can actually put the SMA connector in like so. Here we go. Yay, on frame. Now I've also spliced back some of the coax. I haven't pre-tinned it yet. Now the soldering is kind of small, so I'm going to do that off frame, but there's a very small point on the board where we pulled the original antenna off that this is going to go through hole, and there's a small little tab. Let me get one of my multimeter probes and zoom in real quick. There we go, that's much better. Alright, now if you notice right here, this is actually the signal lead right there. It's a through hole, so I'm going to route the wire through there. And this little tab right here, right next to it, is a ground point. Also, this box right here is a ground point. And you see there's 3 little holes here, also ground points, also ground points. I've confirmed this with my continuity meter, a continuity tester on my multimeter. Now, because this is so small, I'm not going to bother try doing this on frame because it's a real pain in the ass. I'm going to go ahead and solder this in, and we're going to go to the next step to this mod. There we go, mod complete. I'm just going to reframe, finish putting together, a little bit of hot glue. Of course, as always, I'd recommend epoxy or epoxy putty, but if you're new to these sorts of mods and whatnot, hot glue is a very highly recommended suggestion by me, because if you do make any mistakes or anything does break, you can repair it. There we go. Here's the finished mod. Honestly, didn't use any hot glue inside whatsoever. Now, you might actually have to go inside. If you notice, this is kind of splitting open a little bit. You might have to go inside with some hand tools or Dremel accessories to sand down the insides a bit, but pretty much, here it is. I'll zoom out, reframe up, and I'll show you what it looks like with some antennas on it. Alright, that didn't take very long, and the mods are relatively easy. I didn't mention, however, I did not use my Dremel whatsoever for any of the modifications. When modding this radio, I just used a pair of wire cutters to re-engineer the inside and the internals of the radio for the BNC connector to fit. Now, BNC connectors, if I haven't already stated, are very easy to obtain, and they're often used in high-end audio-video equipment. They're very inexpensive. Now, if you get a BNC connector, you can go and get something called Gorilla Glue or expanding AB foam, and you can get some kind of metal of any sort and just design your antenna that is a variable wavelength, like a half wave, quarter wave, third wave, full wave. This antenna on here just so happens to, I think it's half wave for this frequency. Now, this one over here, this tiny little blue radio, this is actually an off-brand piece of crap. I do still need to do a few little minor adjustments to it to get the connector in. I didn't hot glue it in. To cut the actual stub piece off that used to house the old antenna, I just used a coping saw and chopped it off. This is housing a standard SMA jack. Again, they're very easy to obtain. They're standard amateur radio supply shops will have them. You can go online. I actually do offer supplies for both Wi-Fi and ham radio if you guys need. I dropped a whole bunch of money that I don't have to buy a whole bunch of supplies so you guys can get what you need. If you want to mod your radio and you want to get into amateur radio and ham radio in general, and you want to do this mod and you need help, feel free to contact me through the forums. IRC would be better. Please don't email me directly because it's a community-based show. If you email me directly, I can only help you, and the next person that has that same question that you just asked, I have to help again. So if you have any questions or comments, bring it to the forums or come on IRC. I'm not the only person that knows about this stuff. There are a bunch of hams in IRC already, and even more people that are into radio. So, any questions or comments, go to the forums, show notes. I'll put a bunch of links up so you have some understanding about this stuff, and hopefully this sparks your interest in getting into amateur radio in general. In later segments, I will be doing antenna design, both applicable for ham radio in the 70 centimeter band, amongst others, as well as FRS and PMR. So stay tuned.